It's a very sobering feeling to be up in space and realise that one's own safety factor was determined by the lowest bidder on a government contract.
The Interplanetary Podcast. The exploration of space for the benefit of all mankind. Your hosts here in London, Matthew Russell and Jamie Franklin.
Oh, yeah, baby, Alan
Shepard. Alan Shepard there. First American in space, Matt, May the 5th, 1961.
Only 3 weeks after Yuri Gagarin had orbited the Earth.
Yeah, that's not too long after, is it?
He must be a little bit gutted.
Who was the first American to orbit Earth?
It is, of course, the genius John Glenn.
Oh, yes.
On Friendship 7 in 1962, February the 20th.
It was a beautiful day.
Alan Shepard, what a dude.
Absolute dude.
Probably a name that should be more famous, really.
I reckon so. I'm pushing it.
Yeah, well, he has been to the moon as well, I suppose. What else happened on this week, on the 4th of May?
Well, STS-30. It was the 29th NASA Space Shuttle.
Yeah, it's a bit misleading name, isn't it, that STS-30?
Yeah.
And it's 29th. But yeah, 30 years ago. 4th mission of Space Shuttle Atlantis and the 4th shuttle after the Challenger disaster.
Absolutely. And this launched from Kennedy Space Center in Florida. And you'll want to know that it was from 39B, Matt, on the 4th of May, 1989. Who was commander?
The commander was David M. Walker on his second space flight. Well, and who was the pilot?
Well, it had to be Ronald J. Grabe. Is it Grabe or Grabby? I'm going with Grabe.
Whenever we go with a pronunciation, it's always wrong.
Bouquet or buckets?
Yes, Mark C. Lee on his first space flight. But the most veteran on that one was Norman E. Thagard. Yeah, he was on his third. And of course, there was the first woman after Challenger, Mary L. Cleave, a New York biologist.
Absolute legends.
The really interesting thing about STS-30, though,
go on,
is the fact that it launched the Megellan spacecraft, the one that went to Venus.
Yes.
So not only did it map the surface of Venus using this thing called a synthetic aperture radar, by the time it had done it, there was more detailed maps of some parts of Venus than there is on some parts of our own planet.
What?
That's how great that satellite was. And it's still the most detailed Venus map. Maybe we'll see a better one by the time that the Russians have got their act together and got Venera D off into space. But the earliest that's going to go is 2026.
Yeah.
Yeah.
Yeah, it's another 7 years wait. But, we're patient men.
So, yeah,
sometimes.
A lot of what we know is because of the Magellan spacecraft. And there's some other really interesting things about this. So it not only did it map the sort of surface topography, as they say, it also measured the gravitational field of the planet so that you can learn a few things. It also did a few other experiments. I'm going to get onto one called the windmill experiment a bit later on, which is really cool. But first of all, you've got to talk about how it actually got from a space shuttle out into space.
Well, let's break it down.
It's the first interplanetary mission that was launched from the space shuttle. So that's a big tick right there.
Huge tick.
Yeah, and one of the things it did do was do this special trajectory to get to Venus called a Type 4 heliocentric orbit, which goes 1.5 times. Yeah, well, it goes 1.5 times around the sun, and ended up at Venus in 1990. They could have used a quicker one, but the orbit, the kind of launch window opportunity that it had been taken by Galileo. And if you want to know more about Galileo, obviously you can go and listen to our hilariously titled podcast, Galileo, Galileo, Galileo.
Who'd have thought of that joke?
Well, podcast 110, Galileo Figaro.
Figaro! You didn't know I could get that high, did you?
No, you're the Roger Taylor of the Interplanetary Podcast.
Yeah, I am. Yeah, I'll take that.
Yeah, you're the good-looking one.
Big time.
And I'm the buck-tooth talented one.
I wish.
Although I don't have buck teeth or talent.
Come on now.
Yeah, so get this, first spacecraft to do aero braking to circularize its orbit. So it kind of used the Venus's atmosphere to slow it down and get itself into a circular orbit, which is pretty
very cool.
But the one thing that it used, and I didn't really know much about this, I had heard of this, is the IUS, which became known as the inertial upper stage, but it was known as the intermediate upper stage until the Centaur wasn't going to be used anymore. So it kind of is a bit like a Centaur, which is, for those geniuses out there, know that is a kind of upper stage of a few rockets, including the Atlas. It's a solid rocket booster, which I always think is really weird. A solid fuel thing that has to be really accurate always seems a bit bizarre, because you light it and that's it. There's no kind of thrusting up and down. But yeah, two-stage solid rocket. When it's in its interplanetary mode, and this was the first time they'd ever used it for this interplanetary mission. And by the way, they couldn't wait to get this spacecraft out of the shuttle. So they pretty much immediately, as soon as the space shuttle had got into space, it was like, right, get this thing out of here.
It's like, gone.
Let's get it out, because I guess it's quite dangerous having something so explosive as this upper stage thing in your cargo bay. So they were very chuffed to get it out. So it was almost immediately, as soon as they got into space, they launched this thing. And
well, as Chris Hadfield once said, Matt, it's pretty much like sitting on a bomb.
Yeah, well, as we heard from the Shepard quote right at the beginning.
That's very true.
It's like sitting on a bomb that's being built by the lowest bidder.
Yeah.
But
for
having
real.
Having an extra bomb inside your cargo bay is a little bit disconcerting, isn't it?
Yeah.
So what's really cool, and we've talked about this before, the Obert effect, which the interplanetary version of the IUS, what it does is it's two-stage, so it fires off, and then as it goes round the Earth to get a little bit of speed, as its lowest point where it's going its fastest in this kind of elliptical orbit, that's when it fires its second stage, and you get that extra escape velocity because of the Obert effect. Yeah, that IUS has been used for things like the Galileo probe, the Ulysses Sun probe. So it was pretty important development.
Really important.
Yeah, and in fact, they launched the Chandra X-ray Observatory as well.
Okay.
It's a funny-looking spacecraft. And not only that, it was made up of all the spare parts of Voyager, Galileo, Ulysses, and Mariner 9. So they just cobbled this thing together.
Well, we should put a picture up on our Instagram account, our world-famous Instagram account.
Yeah. I mentioned earlier on about the windmill experiment.
Oh, yeah.
So this windmill experiment, after it had been doing its mapping, so in September 1994, the mission was coming to an end. So what they decided to do, very similar to what we saw with Cassini, is that they decided to plunge it a little bit into the atmosphere. Mm-hmm. So they dropped it down into the atmosphere, and then using the solar panels, which are kind of in a cross shape, it ended up being like a kind of windmill in the upper atmosphere.
Okay.
And from that, they were able to, and the way that the thrusters were needed to stop the spacecraft from spinning, they were able to get basic data that's been used ever since to help design even Earth orbiting satellites and how they use aero braking and stuff like that, and how the upper atmosphere interacts with them. So it was a really important experiment.
Well, that's a bit clever.
Yeah, and after a couple of weeks of doing that experiment, they dropped it down even further into the atmosphere. It's going 7 kilometers a second, and eventually burnt up. Eventually burnt up, but some of it may have made it down to the surface. So STS-30, all in all, was a pretty exciting mission.
Well, I'm tipping my cap.
Yeah, absolutely. 30 years ago.
30 years
ago. Happy birthday, STS-30.
Happy birthday.
So, Jamie, what's been going on in the world?
Well, lots of space news, as per this year, really. But Eric Berger, Ars Technica, was saying that NASA has informed the White House that it will need... Are you ready? Are you sitting down, Matt?
Yeah.
It will need as much as 8 billion a year for the next 5 years to speed development of the SLS rocket, lunar gateway, lunar lander, new spacesuits, and related hardware for a 2024 landing. That's a lot of money.
Well, just think about it just for a second, right? You've got SLS continually being delayed, right? Even Elon Musk with his Dragon, it's now got a serious delay. We don't know what the lunar gateway even looks like. That we don't even know who's building the lunar lander.
No.
Spacesuits have been seriously delayed, and we're still using spacesuits, like we said, from the 70s and 80s.
Yes.
And somehow all of that has got to be turned around, and we've got to make that whole work by 2024.
Yeah,
and
just the 5 years.
So what do you reckon the chances are that's going to happen?
I think, and I'm normally really positive, you know me, but I'm going to say slim to none. That's ridiculous.
Yeah, well, if the budget is 20 billion and that budget pays for the International Space Station, all these, amazing journeys out into the solar system, all those amazing probes, Curiosity, etc., 20 billion, and they're asking for an extra 8 billion. That's 40% more. It's not very likely.
Yeah. Well, I just think they're getting a bit excited. I think they need to calm down and stop, yanking our chains.
Now, if you want an example about just how hard space is, it's taken 10 years for NASA to do an investigation into these two really annoying launches that they had. So this thing, a launch vehicle called the Taurus XL, failed, and that lost their orbiting carbon observatory, the OCO, and my favourite mission of all time, the name Glory Mission.
Yes.
named after our old band, Jamie.
Yeah, the Glories.
The Glories.
Our infamous band.
And it turns out that there's a company called Sapper Profiles Inc. who lied about the certification of their aluminium components, and that these things were critical in the nose cone separation, the ones that they've got, I guess, explosive bolts, and basically that it's criminal. It's criminal what they did, and they've had to pay $46 million in damages to not just the US government but loads of other commercial customers because it's been going on for years. But listen to this statement if you want to sort of realise how horrible that is really in the grand scheme of things. It says, when testing results are altered and certification are provided falsely, missions fail. In our case, the Taurus XLs that failed for the OCO and Glory missions resulted in the loss of more than $700 million. And worse for me is years of people's scientific work.
Oh, God.
It is critical that we're able to trust our industry to produce, test and certify materials. In this case, our trust was severely violated.
Makes me feel sick. And
Imagine,
as you say, more than the money.
Isn't it?
I mean, the money is one thing.
People's livelihoods.
The years of research and work, overtime. Could you imagine the hours?
It's that horrible thing, isn't it? Imagine you're at university and you get involved in this project, and then that goes on for 5 or 6 years, and you finally get this project off the ground and they start building it. Then they go for a launch date. You could be 8 or 9 years in at this point, and that's your career. And then it just blows up on the launch pad. Well, blows up when it was being, deployed. And then
which would be horrible to happen in any circumstance, but to happen knowing that people lied and faked documents. Oh, good God. Well, hopefully we've all learnt from that.
Yeah, well, it just goes to show how difficult it all is. All these tiny components all need testing and testing and testing. Everything is at its limit of possibilities. So that's why it's so hard. That's why it's so expensive.
Matt, I'm going to throw some words at you, and then you're going to tell me what the story is. Okay? Cargo postponed. Space station glitch.
Oh, I like it. Well, I think this is to do with there is some kind of glitch with the power system on the International Space Station, and NASA have basically asked SpaceX to delay their launch of CRS-17 so that they can fix the problem. Because one of the things it powers, this power system, the glitch on the power system, one of the things it powers is the Canadarm2, which of course is necessary to drag the capsule.
Very necessary.
Onto the ISS. It can't dock, unlike Crew Dragon, which was the really cool thing about the Crew Dragon docking a couple of weeks ago. So, so it looks like that's going to happen today as this podcast is launched, but maybe not. So, we won't know until next week.
I'm keeping my toes
but
crossed.
I'm sure our listeners will see it in their social media feeds as it goes up, and we'll be watching the launch, I'm sure.
Definitely. What's going on in China, Matt?
Yeah, China at it again with their Long March 4B.
Oh, go on.
Lifted a couple of scientific Earth observatories up into the heavens.
It's my favourite type of orbit.
What I really like about Chinese launches is that the kind of debris that comes down just lands any old place. So, yeah, the used booster of this rocket just smashed down on a highway somewhere and was
absolutely mental, isn't it?
Blocking traffic.
I just don't get how that can be so shoddy.
Well, yeah, they've obviously just built their launch facility in completely the wrong place.
Definitely, it sounds.
You would have thought China was big enough to be able to build a launch facility where they didn't have to fly it over. You
get those notices on UK highways that say, like, take a rest.
Might be crossing.
Sort of thing, yeah. Deer crossing or whatever. Chessington World of Adventures next left. But imagine a sign that said, watch out for falling satellites.
Pretty crazy, wouldn't it?
Pretty mental.
What would be the red triangle with a falling rocket casing?
I'd like to see that.
There's one piece of good news for SpaceX.
Please, because we've had some bad news today.
They've not really had a great week or a great couple of weeks for show. Yeah, the FCC have allowed them to place their 1,600 satellites, their Starlink, their internet in the sky, into a much lower orbit. Because they were going to put it in at 1,150 kilometres high. Now they're going for 550 kilometres. And SpaceX have always argued that would mean that it's they wouldn't have to worry about disposing of the satellites. Even if they lost control, they would just decay naturally. So you wouldn't, there's no space debris problem. And not only that, of course, it means that you've got a lot less latency with the internet. So you might be able to even do a bit of gaming across your Starlink internet connection.
Hell yeah. So what's the score with these? Remind me about these Starlink satellites, Matt. So this is providing Wi-Fi for what?
The entire world.
When do they propose that this is going to happen?
And in the next kind of 3 or 4 years.
Global internet. I mean, that is amazing, isn't it?
OneWeb really didn't like this. But of course, I suppose, they're the competition. So, the race is now on to get this. And I noticed that Starlink, there are going to be some Starlink launches probably this month.
I love
in the month of May. So it's all starting. It's all starting this.
I'd like to know more details about this. I'm going to look into it.
Yeah, well, maybe we should have a internet constellation special.
I think we should.
Jamie, I'm very, very pleased with my space word of the week.
I'm pleased with it too. This week, we are looking at the word Steve.
Steve?
Yeah, Steve. Yeah. Steve.
A surprisingly common, or at least not rare, atmospheric optical phenomena. Can you describe what it looks like?
I mean, when people go and look at the aurora, obviously it's very often a green kind of sheet that moves actually quite quickly. I don't know if I've mentioned this, Matt, but I've seen it twice.
What, you've seen Steve twice?
Oh, I haven't seen Steve twice. I haven't seen Steve once.
Oh, yeah.
But I have seen the Northern
Do you know
Lights.
what? I was starting to panic then if you'd seen Steve as well. Maybe when I go to see the aurora, I get to see Steve.
That would be genius. Well, Matt, this is a purple and green light ribbon in the sky. formerly discovered in late 2016 by members of a Facebook group, which I'm going to definitely follow, called Alberta Aurora Chasers.
Yeah, a photographer, Chris Ratzlaff, called it Steve from the cartoon character from the film Over the Hedge.
Right, and that's apparently because they were calling characters Steve when they were unknown.
Yeah.
Is that right? I think that's right.
It's a bit like English people in restaurants calling the waiters Dave because they don't know their name. So, yeah, Steve, Dave. I reckon, I suspect, had it been a British person that had spotted it, then it would have been called Dave.
Dave, or, John Doe.
I don't think it would have gone with John Doe. But, yeah, this has actually caused another of my favourite words of the week, which is backronym.
That is cool.
Yeah, a sort of backwards engineered acronym. So Steve, the NASA have adopted the word Steve, and someone had basically cobbled it together, and it meant strong thermal emission velocity enhancement.
That is cool.
Yeah. So yeah, now it's an official thing, Steve. That's so cool, isn't it?
Totally official. So basically, backronym is taking something that somebody's coined and putting an acronym into it to make it fit.
Yeah.
Am I right?
Well, I kind of feel a lot of these are backronyms, like JUICE. What does JUICE stand for? It's like Jupiter Ice Mission or whatever it is, and it's like, oh, it makes juice. I'm sure they come up with these acronyms. It doesn't quite make an acronym; it makes an initialization, and then they kind of engineer it to become an acronym. So I suppose, but this is a proper backronym, as in the word existed, and then they came up with.
I quite like IPIS.
IPIS.
It's the Interplanetary Podcast is so cool. Oh no, that doesn't work.
That's IPISC.
Interplanetary Podcast is special. How's that? Is so special.
Well, I quite like space word of the week is swath.
I like that.
Oh no, it's not. It's not. It's swatwa. Swatwa.
Listeners, if this wasn't edited out, it's been a really slow show.
So, no, absolutely. So, remember when we had old Matt Taylor on? He worked on the Swarm mission, the ESA Swarm mission. Well, analysis from that satellite shows that Steve is really a 25-kilometre wide ribbon of hot plasma. And get this, it's at an altitude of 280 miles. So sort of up where the International Space Station is. Now,
I love this fact. Temperature of 3,000 C and flowing at a speed of 13,300 miles per hour compared to 22 miles per hour outside of the ribbon. That blows my mind.
Yeah, so something's happening. It's making the particles up there move incredibly fast and heat up to 3,000 degrees centigrade. It's absolutely bizarre.
Yeah.
But in a quite a recent paper, because this is such a recent phenomena as well, people sort of spotted it but didn't realise the significance of Steve. So, yeah, there's a scientific paper from August 2018 by B. Gallardo Lacote, J. Liang, Y. Neshmuri and E. Donovan. And they say it's completely distinct from the aurora because it's not particle precipitation, so it's not, charged particles. And it must be basically a sky glow caused by and generated by a new and fundamentally different mechanism in the ionosphere. So it's only ever been spotted with the aurora, though. But I wonder if that's because everyone's looking up and spotting it.
Yeah, this could be it.
I think it is associated with the aurora, so there must be something going on.
Yeah.
And it's not been spotted at certain months as well, so NASA think that it might be a seasonal thing as well.
Where has it been observed?
Well, it has been observed in the United Kingdom. So and much sort of further south and nearer the equator than the aurora is. So I'm going to start looking out for it, for sure.
We need to. If you haven't seen Steve recently, get outside, head north, wait till it's very cool and very clear. That's what I'm saying.
To our Canadian listeners and to our New Zealand listeners, you can go out there and see Steve, as can our English and Scottish and Welsh listeners. People from Northern Ireland maybe can see it. So if you take a photograph, please send it to us, please.
If you have seen Steve, please get in touch. We would love to hear your stories. This is something we're now going to be hunting, isn't it, Matt?
Yeah, I'm going to go Steve hunting. Or
Let's
SH. Shh.
Oh, yes.
I'll tell you what is incredible, and this is a new story that I didn't go completely massively high, but I think this is really, really quite amazing, is what's happening with these gravitational wave detectors.
Oh.
So they've been upgraded, and I'll say how they've been upgraded in a bit, because it's actually really amazing. But they're starting to see gravitational wave detections every week now.
Every week?
This is really exciting.
Wow.
So on the 25th of April, this is how recent this is. 25th of April, there was a detection that looks like it's two neutron stars that collided 500 million light years away.
Whoa.
And then you've got on the next day, on the 26th of April, potentially the first ever observation of a black hole and a neutron star being swallowed up by it. And that's 1.2 billion light years away.
That's far.
Let me read that again. 1.2 billion light years across intergalactic space. So this is really exciting. And that new whole thing of a neutron star going into a black hole is really, really exciting, because that opens itself up for multi-messenger astronomy, because you've got, with two black holes, you might not see any kind of light associated with it, or any kind of, electromagnetic radiation coming from that particular event. But with a neutron star falling into a black hole, we should be able to pick it up with our other great observatories, big ground-based telescopes, our Hubble, Chandra, etc., XMM Newton, all these kind of brilliant satellites that you can all turn into that direction and just try and find what it was that went off. So you know where it is. You can measure different properties and how much light and what kind of radiation came off. Maybe even your kind of underground particle detectors pick up neutrinos and stuff like that. Really exciting.
God, it's absolutely amazing, isn't it?
Yeah, it's super exciting.
Damn.
So how have they improved it? It's like absolutely incredible, this is, because it looks like one of these methods, which is this high efficiency mirrors. So the mirrors that bounce the lasers off, they're making them better and better and better, so that they don't heat up, so that the more of the light gets reflected, and basically they're improving the mirrors. But the one that I really, really like the sound of. Now, Jamie, have you ever heard the joke, a policeman pulls over an electron, and this electron is speeding?
Right.
And he makes the electron wind down his window, and he says, excuse me, electron, do you know how fast you were going? And the electron goes, no. And he goes, you were going 200 miles an hour. And the electron goes, oh, I'm lost now. You see, there's your astrophysicists out there that get the joke. It's a joke about the Heisenberg uncertainty principle.
Oh, God.
So you can't know. You can know the position of an electron really well, or you can know its speed really well, or its velocity, but you cannot know them both at the same time. So the more you know one property, the less you know the other, right? And there's a lot of people who don't get it, and I certainly don't. But like you kind of man on the street is, they may get annoyed by this and think that somehow it's just it's just scientists being stupid, but it's this that explains things like how stars collapse into black holes, and how the iPhone works, and how LEDs work, and things like that. It's a fundamental part of the modern world, the Heisenberg uncertainty principle. So
that is incredible. But I like the idea that somewhere in the world, someone's listening to this podcast in a room full of quantum physicists, and they're all just bent over laughing.
Yeah, they'll be going, oh, for goodness sake, that's such an ace joke.
These guys. I'm going to steal that one.
So anyway, what's this got to do with LIGO? Well, I'll tell you what it's got to do with LIGO. So what they've done is they've created this thing called squeezed light. Now, as far as I can understand it, and if you understand quantum physics, you don't, according to Richard Feynman, which is pretty cool, I think what they've done is that they've made one of the properties of the light, the amplitude, more noisy. And that way, when they're trying to measure the frequency or the phase of the light, it's more accurate. And so this has made like the thing that they're trying to measure in the light, they're not concerned about the amplitude of the light, they're more concerned about the phase and frequency of the light. So by making the amplitude more noisy, it actually makes the measurements of the frequency and the phase more accurate because of this Heisenberg uncertainty principle.
Yeah, that's insane.
How cool is that?
That is Trez cool.
Trez cool.
Or hot, as we say.
I'm just going to move straight to space fact of the week.
Well, let's do it. We might actually get a podcast out that's under 45 minutes.
So, yeah. Space fact of the week.
Here we go.
What, is that an acronym? SFATWA. SFOT.
Fatwa.
SFOT.
No.
SFOTWA. I reckon we can backronym it.
You reckon?
Yeah. So
let's do it.
Huge news, I think, is we've talked about this on a few podcasts. I think it was like in the sort of 121, 122 kind of area of podcasts where we started talking about the Hubble constant and how there's a big discrepancy between the cosmic microwave background answer to what the Hubble constant is and what the answer is from measuring all these things like Cepheid variables and supernovas and using these what's known as standard candles. And as we talked at one point, standard sirens was our space word of the week.
That's right. I loved that one.
Yeah. And so you can build up a cosmic ladder by measuring the distances into certain galaxies and then measuring out to even further galaxies and measuring out to even further galaxies. And the more accurate you can make these rungs of the ladder, as it were, the more you home in on this Hubble constant, right?
Yes.
So they're trying to make these as accurate as possible because they're trying to work out whether the discrepancy between the cosmic microwave background answer to the Hubble constant and this one that's generated from the cosmic ladder, whether there is actually a difference or whether it's a statistical blip. So there's a recent paper out by the Nobel-winning astronomer Rees and et al., and it's called Large Megellanic Cloud Cepheid Standards Provide a 1% Foundation for the Determination of the Hubble Constant and Stronger Evidence for Physics Beyond Lambda CDM.
Now that's a sentence.
Yeah. Using data from NASA and ESA's Hubble Space Telescope, Adam Rees, he's working with a team called SHOES. Now, that's definitely a background.
Here we go, definitely.
Which stands for Supernova Hubble Constant for the Equation of State. SHOES. And they've basically significantly lowered the possibility that this discrepancy is a statistical blip. So they've used Hubble to measure 70 Cepheid variables in the Large Megellanic Cloud that you can see from the southern hemisphere, which I really must go and see one day.
Yes.
And that is now calculated to be 162,000 light years away. And by really using this data and going further and further into it, they've managed to get an accurate rung on this cosmic ladder. They've now reduced the uncertainty to the Hubble constant value to about 1.9%. Now,
bad.
the reason, that's not bad at all. And that means that because it's such a significant improvement, that the chances of it now being a fluke are 1 in 100,000 rather than last year's estimate of being 1 in 3,000. See, 1 in 3,000, this could still be a fluke. But 1 in 100,000, it's, the plausibility of it being a disparity by chance is almost vanished. So this is pretty big news, isn't it?
That is big news.
Yeah, so the new Hubble constant, if you want to know, is 74.03 kilometres a second per megaparsec.
Write it down, people, now. You are going to need this.
So if you're wondering what that means that if for every 3.3 million light years further away a galaxy gets, it's moving 74 kilometres a second faster as a result of the expansion of the universe. So it's a real tangible thing, this Hubble constant. And what's causing it is the biggest question in cosmology, and the fact that there's something we don't know, the fact that it's changed from the cosmic microwave background to the present day when you're looking at these cosmic ladders.
Here we go. Here's a quote from Adam Rees. The Hubble tension between the early and the late universe may be the most exciting development in cosmology in decades. This mismatch has been growing and has now reached a point that it is really impossible to dismiss as a fluke. Wow.
This basically has really put a very strong flag in the discovery of a difference, but now we've got to diagnose the actual source of the difference, and so we want more and more accurate measurements of the Hubble constant. And basically that's underway now by using what we were talking about earlier on, LIGO and things like that, and the gravitational wave sources should really help with these, standard sirens that we now have.
Yes.
Yeah, not only have we got standard sirens, we've got ESA's other great observatory in the sky, Gaia.
Oh, yes. Go on, Gaia.
Because that's able to determine the parallax error of things. It's able to put one of the rungs of the ladder extremely accurately. So this is really exciting times to be in cosmology. So if you've got any kids who are choosing between cosmology and banking right now as they go to university, please make sure they choose cosmology.
Just do what you have to as a good parent.
Oh, yeah. Just be loving to your children. Don't force them into something because Matt from the Interplanetary Podcast said so. That'd be bizarre,
yes,
if not like child abuse.
Yeah, definitely don't do that. What we're saying is, maybe inflame their knowledge.
Yes.
Why don't you create a backronym together?
Yeah, sit down and create a backronym for it's time for lunch or something like that, Jamie, I've learnt an awful lot this week.
So have I. I might have to listen to it back. It was another complicated one, but
yeah,
I'm all about learning, Matt.
So yeah, there's no interview this week. We got some crackers lined up.
We have.
Keep listening, but it's quite nice, isn't it? It's quite nice to do a normal show again. We've had such a long run of interviews,
such a long run of interviews. But we hope that you've enjoyed our dulcet tones a little bit more, and thank you again for listening. And Matt, if somebody's new to the podcast, what are the basics they should do?
The basics, I think, is it'd be really, really nice to do the iTunes review thing, mainly because that really helps us with our getting more and more people to listen, people to discover us. Think of someone sitting in their bedroom going, I wish there was a kind of space podcast that was a little bit light-hearted and had English voices and maybe a little bit silly at times. I wish there was something like that. And they just don't know. We just don't know that we're out here.
A review
would be great.
Can definitely help them along their search.
Of course, you could go to Patreon/Interplanetary if you wanted to have a look at what's there. There's actually some other content there that's completely free for you to have a look at, like the latest Alan Bond interview, which is unbelievably interesting.
Only available on our Patreon site.
Yeah, it's available on our Patreon site, completely free, even if you don't become a patron. So
that's how good we are to you. And Matt, do we do adverts to make loads of money and be really annoying to people? We don't do that.
No, we don't have sponsors, and we don't have people altering what we have to say. If we want to say Elon Musk, you're a lunatic, we're free to say it.
We're not going to, but if we wanted to. I'm just trying to get a free Tesla.
Yeah, he occasionally does switch on insane mode, though, in his Tesla.
That's
and
true.
Maybe in his brain.
Tesla, for all your car needs. Surely get a free one now.
Yeah, easy.
I mean, what better advert is there than that endorsement?
Yeah, what's your favourite car? Mine's a Tesla, Jamie. What's yours?
Yeah, I like a Tesla myself.
Yeah, after all these hour-and-a-half episodes, I think people will be relieved to be able to catch up with this shorter one.
Okay, well, listen, have a good weekend, people. And don't forget, look up.
Bye-bye, Spodcats.
Bye.
Bye.